Hello to all the beautiful people listening here. Let us start today with the beta-oxidation of fatty acid. So I have written here the formalized structural formula of the fatty acid. Now let us start with the definition of beta-oxidation of fatty acid. From its name we can tell that it is the oxidation in the beta carbon of the fatty acid. So this one is our alpha carbon and this one is our beta carbon. So oxidation in the beta carbon of the fatty acid is known as beta oxidation of the fatty acid. So it leads to the splitting of two carbons from the fatty acid. So after the definition, let us enter to its steps or pathway. So we have generally three steps for its oxidation, which are activation, transportation and beta oxidation proper. First one is activation, second is transportation, and third one is beta oxidation proper. So we have here the three steps. In beta oxidation proper, there are four steps altogether, which are oxidation, hydration or hydrolysis, again oxidation, and finally release. So let us go with these steps briefly. So first let us start with its activation. So first step is the activation of the fatty acid. So this is our fatty acid. Now we will utilize one ATP here and it will get converted to AMP and PPI. Similarly, coenzyme is added here for the activation, and finally we will get a compound. So this coenzyme is replaced here, so it will form this compound, which is known as acyl coenzyme A. This compound is acyl coenzyme A. If we expand this step further, let me expand this. So first we have our fatty acid, that is utilization of ATP here, and we will get PPI. Similarly, Mg2 plus is also utilized here. Then you may think, where is AMP? So AMP is added here. And again, when coenzyme is added, it will form our compound acyl coenzyme A. Replace AMP here and become acyl coenzyme A. So we have acyl coenzyme A. Beta oxidation of fatty acid takes place in the mitochondria. So we have to transport this acyl coenzyme A to the mitochondria. But we all know that inner mitochondrial membrane is impermeable to fatty acids, so there is a special carrier system which is known as Carnitine carrier system. So our second step is transportation. Transportation is carried out by Carnitine carrier system, through which this acyl coenzyme A is transported through the inner membrane of the mitochondria inside the mitochondria. So this is transported. After transportation, next step is the beta-oxidation proper. Third step is beta-oxidation proper. I have already told that it comprises of 4 steps, which are oxidation, hydrolysis, again oxidation, and cleavage. So let us go first to oxidation. We all know that oxidation means the removal of the hydrogen. So here one hydrogen from here and one hydrogen from here are removed. That means double bond will be formed here and we will get a compound like this. Then second step is hydrolysis. Hydrolysis means addition of water. We have H2O. So when we break it down, we will get H plus and OH minus. So there will be addition of these ions here. So let us add this. So here in the beta carbon, OH will be added, and here hydrogen will be added in the alpha carbon, and we will get this compound. Third step is again oxidation. So here oxidation in the beta carbon will take place. So we will get one hydrogen will be removed from here. So we will get compound like this. And the last step is the cleavage. So we will get 2 carbon atom here, which is acetyl coenzyme A. So the cleavage is from here and we get. So here we have coenzyme, but here there is nothing, so coenzyme is added here. So we will get this. This compound which we have already discussed, this is acyl coenzyme A. As it's this R is not defined, so it is acyl coenzyme A, and this is acetyl coenzyme A, which is our 2 carbon unit. Now let us give the name to these compounds which are formed here. This one is acyl coenzyme A. As I have already told, it is acyl coenzyme A. This one is our delta square trans enol coenzyme A. This one is our delta square trans enol coenzyme A. This is our beta hydroxy acyl coenzyme A. This is keto acyl alpha keto acyl coenzyme A, and last last one, as I have already told, it is acyl coenzyme A and it is acetyl coenzyme A. So now let us write the names of the enzymes involved here. As we can see here, acyl coenzyme A, here or delta square transenol coenzyme A, beta hydroxy acyl coenzyme A, ketoacyl coenzyme A. The enzymes here will be, first let us write the names of the enzyme, then we will discuss about the energy production here. So I think I should make it a little bit clear rather than this other. Here, the enzyme used for the conversion of acyl coenzyme A to delta square transenol coenzyme A is thyrase. Similarly, the enzyme for the conversion of delta square transenol coenzyme A to beta hydroxy acyl coenzyme A is this one here, the enzyme which helps in the conversion of acyl coenzyme A to delta square enol coenzyme A is, we have acyl coenzyme A here, so the enzyme will be acyl coenzyme A dehydrogenase. As we have delta square transenol coenzyme here, we have enol here, and this step is our hydrolysis step. So the enzyme is enol coenzyme A hydratase. And here we have ketoacyl coenzyme A formation. So the enzyme will be ketoacyl synthase. Finally, in the last, the splitting of alpha ketoacyl coenzyme A to acyl coenzyme A and acetyl coenzyme A is done by the enzyme thyrase. So, this is our beta oxidation proper. Let us now study about its energetics. So, this is NADPH dependent reaction, and this is also NADPH dependent reaction. Rub it out first. So we have two oxidation reaction during the beta oxidation proper. So first we have converted acyl coenzyme A to delta square transenol coenzyme A, and then this one was converted to beta hydroxy acyl coenzyme A, and this one was converted to alpha ketoacyl coenzyme A, and finally this was clipped into acyl coenzyme A and acetyl coenzyme A. So this one was our first oxidation reaction, and this one was our second oxidation reaction. So here FAD plus is converted to FADH2, and here NAD plus is converted to NADH2. Now let us write about the energetics. So we have acetyl coenzyme A, which is 2 carbon unit. Let us consider our fatty acid will be palmitoyl coenzyme A. So it is a 16 carbon compound. So if there was palmitoyl coenzyme A, then that means 16 carbon atom. We would have get acetyl coenzyme A. It is 2 carbon and palmitoyl coenzyme A is 16 carbon. That means altogether we would have get 8 acetyl coenzyme A. So 8 acetyl coenzyme A plus here we have FADH2 and NADH2 for the energy. So if the fatty acid was palmitoyl coenzyme A, then there must be altogether 7 reactions, as at last there I have already told there are altogether 8 acetyl coenzyme A. But at the last reaction, remember here we have written acyl coenzyme A because the R was not defined. But if we take palmitoyl coenzyme A, our R will be defined, and as it is 16, that means even chain fatty acid, then at last we will get 2 acetyl coenzyme A. So therefore only 7 reactions would take place. So we will have 7 FADH2 and 7 NADH2. So altogether in acetyl coenzyme A, when it enters Krebs cycle, it will give 10 ATP. So therefore we will have 8 into 10 ATP plus FADH2 will yield 1.5 ATP. So 7 into 1.5 ATP and NADH2 will yield 2.5 ATP. So 7 into 2.5 ATP. So altogether we will have 80 plus 7 into 1.5, that is 10.5, plus 7 into 2.5, that is 17.5, and altogether 108. So this is not the net energy production, it is altogether energy production from the beta-oxidation fatty acid. But in the first reaction, remember, for the activation of the fatty acid to the acyl coenzyme A, we have utilized ATP. So there we utilize 2 ATP. So 2 ATP. So net energy production will be 106 ATP. This is our net energy production from the beta oxidation of fatty acid. Hope you all guys like the video. Please don't forget to subscribe, like and comment the questions you may have. Thank you.